I wanted to take a minute or two and just talk about the three different kinds of graphs that we'll see a lot of, or take advantage of in spherical coordinates. And that would be what would happen when, for example, when rho is a constant. Well, if rho is a constant, you're looking at all the points in 3 space that are the exact same distance away from the origin, right? And that should be the definition of a sphere, where every single point is exactly the same distance away from the origin. So this is a sphere centered at the origin. Now, part of the reason I wanted to bring that up is when we see stuff like x squared plus y squared plus z squared equals some radius squared, that is our normal definition, our normal equation of a sphere, but that's actually just the same sphere as rho equals k, so you can see we actually got a lot simpler that way. If we want to look at everything where theta is equal to constant, well, what is theta, right? Theta says, go that angle over like this, and now let z be anything. Well, what you're going to get there, if z can be anything, is you're just going to get a vertical plane through the origin. Now, a couple things about that. We're going to be using those for chopping things, but those aren't functions of x and y. So we won't see them as functions, but we will use them as tools to chop things. All right. Finally, what happens if phi is a constant? Well, if phi is a constant, what you're going to get is a cone. Vertex at the origin, like that. And you can see if you're at any point on this cone that the phi is always going to be exactly the same thing. So this is going to be a cone pointing up. Vertex at the origin. Just to recap, if rho is constant, you're looking at a sphere. If theta is constant, you're looking at a vertical plane chopping through the origin. And if phi is constant, you're looking at the equation of a cone, which is really kind of cool.